In this lecture, we will study about the energy transfer in an electric circuit and the thermal energy produced in a resistor. Suppose we have a battery and these are the two terminal of the battery having EMF E, and a resistor R is connected across the battery with the help of these connecting wires, this wire, and this is the resistance, and the resistance of these two wires is negligible, suppose. Now this is the resistance. Now there will be no potential drop across this resistor, this connecting wire, because this has no resistance. So potential at this point and this point will be same, and this is having potential VA, suppose, and this is having VB, and VA minus VB in this case is equal to EMF, because the potential difference in this case is equal to EMF, and the potential of this is VC. So we can say VC will be equal to VA, because there is no potential loss in this wire, and similarly potential of this point and this point is also same. This is suppose VD, and this VB is equal to VD. It means this potential difference, if I say potential difference VA minus VB is equal to V, in that case VC minus VD is also equal to V. And suppose when we connect this wire, current in this through this wire is suppose I, and I is the current flowing in the wire, and in total time T, the total charge which will be flowing through this wire will be equal to I into T. Now when this current I or this charge I into T goes from this side to this side, its potential is decreasing, because this is at high potential, this is at low potential. So it is going from high potential to low potential. So in this process it will be losing potential energy. So how much potential energy will be lost? This will be equal to potential difference into this charge, Q into V. This is the potential energy lost, or this is the decrease in the potential energy. This is decrease in the potential energy, Q into V, and Q we know is I into T. So this I into T into V is the potential energy lost, and this loss in potential energy will appear in the form of thermal energy in this resistor. So this will be equal to the heat produced. So total heat produced in the resistor will be equal to I into T into V in time T. So total heat produced, we can say, is equal to V into I into T, and per unit time heat produced is equal to V into I, because this will be divided by T and this T will be cancelled. So this is V into I. So this H by T is the power consumed in this resistor. This is P, and P is equal to V into I, and as we know V is equal to IR, this is Ohm's law. So if we put the value of V in this equation, this will be equal to I into R into I, and this will be equal to I square R. So total heat produced in a resistor is given by I square R, or we can say P is also equal to, because V into I, so if we write I in the form of V by R is I, so this will be equal to V into V by R. So this is also equal to V square by R. So we can say heat produced in a resistor is I square R, and or it can be also given by V square by R. This relation we can use normally when we use resistances in series, because current remains same, therefore I square R if we use, that will be better. And in parallel circuits, because voltage remains same, so if we use V square by R, this will be better. So we can use any one of them, I square R or V square by R. So total heat produced is equal to V square by R or I square R. Okay, thank you.